Thank you all for being here. I think I know just about everybody in here, and it's nice to see you all. Anyone who doesn't, I'm Jeff. I'm the Director of External Affairs here at the Museum of Idaho. And it's a lot of fun to do programs like this that are not only interesting, hopefully, and relevant to a couple of scientific disciplines, but also super local and also intimately connected with us right here at the Museum of Idaho. And this more so than just about any other presentation that we have done is, I think, a little bit of a look into our near future here at the museum too. And I'm really excited to be able to talk about this incredible collection, because if we're doing our jobs correctly, you're going to start hearing more and more and more about this in the coming weeks, months, and years. And we have just the right person here to talk about it. But before we get to that, we have, sorry, I'm not holding this up like I should be probably. Before we get to that, we have a couple of housekeeping notes. As always, we'll remind everybody to silence your phones if you have them. We have refreshments here. And we get to do a fun little field trip today also during this museum club hour or hour plus. Also, we're going to be in this room talking for a while. We'll see how long it lasts. And then we are going to follow Kristina across the street to our research annex just out behind the museum. It's not far. But we, if there are any concerns about that, come talk to me. We'll figure it out. We'll get you all over there. You're obviously not required to come if you don't want to, but I think you'll enjoy what you see over there. It'll be a lot of fun. And we're going to get to see firsthand some of the wonderful stuff that Kristina is going to be talking about right here. So without further ado, I would like to introduce Kristina Frandson. And normally we don't introduce, or I don't spend a great deal of time introducing our members of the staff when we get up here and speak. We just feel like, well, this is one of our duties, you know us by now, right? But I think that was an opportune time to be able to introduce Kristina Frandson just a little bit, because a lot of you have not yet met her, and yet you're going to get to know her better and better. Hopefully. Kristina Frandson is the new curator of the Museum of Idaho, and we could not be happier about that. She beat out 30 or 40 very highly qualified candidates for the job. You would not believe how many people want to be curators of museum collections. And we had folks from all over the country, even a couple beyond our own borders, interested in coming and doing the work at the Museum of Idaho. And Kristina was absolutely the right choice. And we are so happy to have her here. Those of us on staff have had the pleasure of knowing her for a year to a year and a half now, as she has worked as a contractor on this very collection, the Wasden collection, through a grant provided by the Institute for Museum and Library Services that we were fortunate enough to receive a couple of years ago. So it really helped when we were doing this process, this search for a new curator, that we had somebody right here that we all really liked already. But just a little bit about Kristina's background too. So and she'll go into a little bit more too, and obviously you're welcome to ask her questions as well. Kristina comes to us with a Bachelor's of Science in Anthropology and in Classics from the Franciscan University in Ohio, as well as a Master's of Science with merit in human osteoarchaeology. So if you can think of all your Greek roots there, from the University of Edinburgh in Scotland. She also, which I have not hit you up for this yet, but my understanding is that she speaks Latin, which I think is really cool. And maybe you'll favor us with some Latin at some point. I don't know. There is some Latin on this resume, magna cum laude, other things like that. that speak to her good experience as well. She also comes to us with archaeological experience in a number of different countries, including our own, has also observed and worked on digs in Greece. Gosh, I'm not seeing the other ones. Cyprus? Crete, there you go. This is a Mediterranean island. All right. Anyway, we could talk for a long time about all of Kristina's qualifications, but I think you will get a good sense of her and her qualifications just by hearing her present. And so happy to turn the time to her to talk about digging into the Wasden Archaeological Collection. And so please give a round of applause and a welcome to Kristina Frandson.
Hopefully I don't drop any of the things that I have now. Yeah, I am extremely pleased to be here today to present on the Wasden Archaeological Collection, because I think it's one of the most important collections that we have here at the museum. And I'll see if I can. I think Jeff introduced me really well, so I'll maybe sort of skip me a little bit and introduce Sue Miller, who I'm really lucky to have presenting with me today. I kind of coerced her a tiny bit, but she's one of the original excavators who was out there getting stuff out of the ground at Owl Cave. So I don't know if you want to join me up here, if you want to join me later, Sue, it's up to you. But all right. Yeah, she is incredibly knowledgeable and I think she's one of the most wonderful people I have ever met ever. So when we head over to the annex, I think it'll be a great opportunity to kind of pick her brain for extra details on everything that's happening over there. I guess to begin, I'll give you a little bit of background on the Wasden Caves. It's a cave system formed of 3 caves, Owl, Coyote, and Dry Cat Cave. It's a collapsed lava tube that's located approximately 20 miles outside of town. So it is, as Jeff was saying, super local. And I think it's so far flown under the radar, which is kind of incredible because there's so much going on in these caves that they really should sort of be the forefront of scientific study, really, which is partially why the Museum of Idaho is lucky enough to have the collection and why it was moved here, which I'll probably talk about and touch a little bit more on towards the end of the presentation. But we really want to make sure that these materials are available for future research because they are so significant. Anyways, Owl Cave is the largest of the 3 caves, and it has only been partially excavated, even though out of the 3, it is the most extensively excavated. So only half of it has been not really disturbed, but had archaeologists in there getting artifacts out of the ground. And even though it's only half of the cave, there's already over 80,000 things that have come out of the ground. So if you can imagine what the additional half of the cave plus the other 2, which have test trenches that have been dug in them and have turned up artifacts as well. If you can imagine how those will add to the body of artifacts that we have here already, and to the body of knowledge even that's coming out of these caves. The potential for future research and the understanding of the Eastern Snake River Plain in general is just astonishing. The first excavations that were carried out at the caves started in the 1960s, and they were led by B. Robert Butler, who was an Idaho State archaeologist, and he was leading a crew formed primarily of amateur archaeologists from the Upper Snake River Prehistoric Society. And they they were the first sort of group out there to start getting things out of the ground and realizing that this was a significant cultural resource in the area. Excavations also continued into the 70s, which Sue was there for. And she can talk a little bit more about that later on when we go over to one of the, one of the main focuses of the artifacts coming out of the cave are all of the faunal materials that are coming out of the cave. There's sort of a unique interaction that you can see in the cave between humans and their environment. But there's also a sort of, not necessarily an evolution, but a change in sort of the fauna that we're seeing in the cave as well. So the earliest sort of levels in the cave are 13,000 years ago, and there are mammoth remains down in like the deepest parts of the cave. And then sort of working our way closer to the surface, we have ancient camel remains, dire wolf, cave bear, American lion, bison latifrons.
Is everything okay?
Yeah.
Bison as well, which I'll talk about as well, because around like 9,000 years ago, there was a bison kill in this site as well, which is another huge point for study in the cave, is this bison bone bed layer. There are at least 60.
Yeah, I need to use the computer for a minute to do some math.
The questions are, why are they all there? How did they get there? Was it a bison drive? What is the significance of this bison bone bed, and how does it sort of give us more information about how humans were interacting with their surroundings at that time, which would have been at the end of the Pleistocene and the beginning of the Holocene. So up here, I just wanted to show you these two images. So the first one is a plan view of the excavation. So that's the grid of how everything was laid out. And you can see on this particular one, a lot of the focus is back in the alcove of the cave. It's significant, again, because you can see that on this particular one, they're not showing you that they've excavated the entire cave. Most of the information that they're showing you is been back in the alcove. And what they found back there is folsom fragments and mammoth remains, which is hugely significant because the cave is so deeply stratified that finding these folsom fragments, possibly in association with mammoth remains, can throw into question the timeline of what was going on in the American West at the time, because the accepted timeline for when mammoths were sort of roaming around in North America and when the Folsom culture was living and hunting in North America, they don't overlap. There isn't an overlap there. So the fact that we have a Folsom point and that we have Folsom fragments, possibly in association with mammoth bones, raises a lot of questions. And you can kind of see, again, just with this composite west wall profile, how deep the site goes and how well stratified it is. So they're finding the mammoth remains like way down here, like 6 meters down, which is approximately like 13,000 years ago. And then the bison bone bed is, I don't know if you can see it, but it's up around here, which is like 9,000 years ago. So not only does this show you the stratification, and that's really, really cool and interesting, but it also shows you that the cave was in use for like thousands and thousands of years. So it's significant, even in just that regard, that people knew about the cave and were using it for years and years at a time. This is one image of one of the folsom points, which is that black speck next to the black and white stick in place near the mammoth bones. And then here again, we have a slightly better angle of that folsom point, and then some drawings of some of the other folsom points coming out of the cave. So one of the ways that we can tell that these are folsom points is because they're flaked in sort of like a diagnostic pattern. So one of the diagnostic flakes, which is like the most important one and easiest one to recognize, is a flute flake, which runs on a folsom point almost the entire length of the point. A Clovis point, which is usually what's associated with mammoth kill sites, that flute only runs halfway up the projectile, which we do have out on in one of the display cases on the floor and way out west of it. So if you wanted to see that a little better, you might be able to walk by it on the way over to the annex. But if not, it's out there and you can see it. But another thing that is interesting about these folsom points, and I'm sorry to just stay on it, it's so fascinating. Another thing that they found when they excavated these and took these out and were studying them is that they have one of them has elephant DNA on it, which is I think that's mind-blowing. So that raises another question of how in the world did the elephant DNA get onto this folsom point, and what does that mean? Because just having a point in association with mammoth remains, that's cool, but that doesn't necessarily, that could have happened a myriad of ways. Somebody could have had a folsom point and chucked it in the back of the cave, and it just happened to fall near where there were mammoth bones also in the back of the cave, So the fact that there is DNA on a point continues to be the subject of research, how did it get there? And I think one of the proposals actually that is going to come in that we're sort of discussing with a student is she wants to see if there is a way that DNA maybe could have migrated through the soil with water, to see if maybe it could have been deposited on the point that way, or if the point had to have been used to cut into the remains. I don't know. It's a huge question, which once again rewrites that timeline. But I'll kind of skip over this since I've harped on that point a lot. But anyways, the two teal points are basically showing you that's the end of the Pleistocene. And then the coral point right here would be the beginning of the Holocene, which is the time period that we're in right now. So there's a transitionary phase right there that usually you have the Folsom people and the mammoth, they don't overlap. But in the Wasden Cave, we have a situation where there's a question of, do they overlap? And if they do, what are we going to do about it? Okay, now onto the part that I've been the most, I guess the most hands-on with is the bison bone bed. There are so many bison bones coming out of the bison bone bed. If you think of 60 individuals and a human has 206 bones, so the bison have a similar amount. It's a lot of bones that are coming out of the bone bed. That I'm in charge of cataloging and processing. And there have been multiple efforts to sort of catalog these, but none of them have ever made it to completion, which it is it's a huge project, so that's understandable. But yeah, that's sort of my job, is to go through and make sure that once everything is cataloged, and while that process is happening, research can continue to happen. But some of the main questions that are surrounding the bison bone bed, once again, are how did they get there? Why are all 60 bison there? And one of the main theories is that it was perhaps a bison drive. There's one researcher who flew a drone over the site And depending on how the drone flies over the cave, you cannot see the edge of the cave until you're like pitching over it. So it's not unlikely that a group of Native Americans could have, channeled a herd of 60 bison over the edge and then have them drop into the cave and then, conveniently use that cave to butcher them and, get the meat off of the bones and get the marrow out of the bones, which supports sort of another theory regarding the cave, which is that it was used as a marrow processing site. And while I've been going through the bones and looking at them, one of the things that I've been analyzing is sort of like the taphonomic signatures that are present on the bones. And taphonomy is anything that happens to a bone like post-depositionally. So, well, and even like just after an animal dies. So once the animal is dead and is on the ground and going into the ground over time, anything that happens to the bone, whether that's carnivore damage or like bone breakage or erosion, anything like that tells you a little bit about what happened to the bone. So some of the things that we're seeing are like fresh bone breaks, which could suggest cultural modification to the bones, and in support of the idea that maybe they were breaking these bones to get the marrow out of them, which is a source of nutrients. Another thing that they're studying, and another question about the herd in the cave, is they're studying the ages of the bison to see when the kill took place. And it's suggested, because there's fetal bones, fetal bison remains present, that it was a late fall, early spring drive perhaps. And then another theory that's a little bit more recent is that maybe the herd is a mixed species herd, which would shed a little bit more light on what's happening sort of environmentally on the Eastern Snake River Plain at that time as well, which has been studied with the faunal material coming out of the cave, but mostly using microfauna. I think that's interesting. I don't know. I guess, okay, so the point about that is, if you have a more lush environment, you can have larger fauna. So while you're having these sort of extinction, while you're having this extinction of megafauna type species, and your environment is becoming more dry, etc. I think it's interesting that perhaps in this owl cave bison sort of herd, you have larger and smaller bison species, which is reflected a little bit, I think, in atlas bone sizes, which I'll show you in the annex. So right now it sounds a little bit abstract, but I'll show you when we get over there. I promise. So anyways, now that we have the bones here and they are partially cataloged, and we're trying to make sure that they are available for research, there have been proposals that are coming in from multiple institutions, like Idaho State University and Utah State University. And it has sort of like with anything with anthropology and archaeology, it's an interdisciplinary effort to sort of answer the questions that are coming out of the Owl Cave. We've had proposals to do lithics analysis, pottery analysis, collagen sampling, strontium analysis. I am probably most excited about the strontium analysis one, because that is going to use bison, like little samples of bison teeth to extract these samples of strontium, which is accumulated during like a bison's lifetime, their diet. And it can show you, after you've like taken samples of strontium from around the state, it can show you potentially where the bison were migrating, which is awesome because it shows you the migratory pattern of the bison herd, but also can give you a little bit more of a picture of where maybe people were also following these herds across the Snake River Plain. So all of these things are questions that can be answered from the Owl Cave assemblage, and they are helping to create a better, like a more complete picture of what was happening on the Eastern Snake River Plain in Idaho between like 10 to 13,000 years ago. So I think that's incredible. And I'm really excited to show you the annex so I can show you all the bones because they're so amazing. And that's where my PowerPoint ends. Do you have any questions?